So, welcome everybody. This is Daniel from LieberLieber. Today I have a guest, a colleague from IncQuery, Balázs Gil, who developed together with us, with our ideas, the new AUTOSAR-UML Bridge. We will talk today about how we can integrate the AUTOSAR world in a nice way into the Enterprise Architect world. I'm Daniel Siegel. Probably some of you already know me from previous webinars. I work with LieberLieber since it was founded. I'm into model-based systems engineering and especially in collaboration, integration with other tools than Enterprise Architect. Balázs Gil has a lot of experience in the AUTOSAR space and works for our partner company IncQuery. After our AUTOSAR engineer tool was discontinued, we started to work with IncQuery, and they developed a new tool with all the learnings we had from the 10 years with AUTOSAR engineer in the past. The challenge is one of the topics we will discuss today. Then we will do a live demo, and we will have time for takeaways and question and answers. And in the final part of the agenda, we will tell you about the events that we are gonna be in the next months, so you can meet us in person. Now we have a little poll prepared for you to get you awake. And it's about what's your interest? What do you care for when you think about AUTOSAR, UML, SysML world? So to start it up, we have prepared a little video for you, and then we will go into more details.
The IncQuery AUTOSAR-UML Bridge is the ultimate solution for managing traceability in automotive software projects. The bridge can help you cross the gap between software architecture design captured in AUTOSAR tools and requirements, documentation, and detailed design in UML and SysML. Give your engineers a productivity boost by automatically generating high-quality UML models from AUTOSAR projects with built-in ISO 26262 and automotive SPICE compliance. Automotive software architects and systems engineers spend a lot of time with documentation by creating UML models based on AUTOSAR architecture designs. This is a challenging task as AUTOSAR and UML are significantly different in terms of capabilities and underlying technology. Therefore, doing this transition manually may involve a lot of copy-paste and data re-entry, a tedious, slow, and error-prone process. Furthermore, as a project progresses and complexity grows, keeping AUTOSAR and UML in sync can be a delivery blocker, especially when you are already grappling with tight timelines and budgets. IncQuery is here to help. Our novel AUTOSAR-UML Bridge simplifies your engineering process by allowing your engineers to generate UML models from AUTOSAR projects with the push of a button. This works for both documentation purposes as well as handover automation between architecture and detailed design. The IncQuery AUTOSAR-UML Bridge creates a complete and faithful UML and SysML representation for the entire AUTOSAR model. This UML and SysML model can be further enriched with architectural diagrams such as software composition or behavioral diagrams such as sequence, activity, and state chart as needed. The bridge seamlessly integrates with Spark Systems Enterprise Architect 15 and 16 and supports all versions of AUTOSAR. The IncQuery AUTOSAR-UML Bridge is the ultimate solution for managing traceability in automotive software projects. The bridge can help you cross the gap between software architecture design captured in AUTOSAR tools and requirements, documentation, and detailed design in UML and SysML. Give your engineers
So, Balázs, now it's your time. You're on mute.
Hi, sorry about that. Hope that everyone was able to see the video. Otherwise, it is available on our online platforms on LinkedIn and Facebook. On the next slide, I would like to present the workflow of the imaging model-based design approach. We assume that our listeners are familiar with software development's V model. A huge percentage of our organizations apply this method worldwide. For this step in the V model, use the appropriate technology. EA is used for requirements and high-level design, most probably contains both hardware and software elements, and also AUTOSAR authoring tools used for capturing software architecture. And the UML also, again, in EA can be used for covering detailed design, which is not covered by AUTOSAR modeling approaches. To demonstrate the operation of our tool, we are designing a simplified vehicle air conditioning system with the following functionalities: temperature and humidity control loop, including measurement, actuation, and display. In the example, the user requirements are captured on system level and defined in Enterprise Architect. The next slide, we are moving to the next level. The requirements are mapped to blocks at system architecture, which defines how the functionality is broken down to simpler components. Blocks of the system implementing various functionalities are represented here. There is a temperature and humidity sensor, a display and buttons for interacting with the user, and air conditioning capable of actuating the properties of the air. The application logic will be implemented by the ECU, which will execute the software. Moving further, the software architecture of the application is defined using an AUTOSAR authoring tool. The software composition defines the structure, data flow, and contract of the software requirements, software components, and ultimately the signature of the functions to be implemented. However, there are two major limitations with this. First, there is no direct connection between the system level elements and the software architecture. Defining such traceability is crucial to ensure consistency. Second, AUTOSAR's capabilities end with the software contract. And this is intentional. Providing detailed behavior models for software is out of scope for the AUTOSAR standard, but UML is a well-established tool designed for this purpose. To alleviate this problem, it is necessary to represent AUTOSAR model elements in the UML domain, for example, by recreating the same model in EA. Manual data entry is expensive, error-prone, and complicated to update. Keeping AUTOSAR and UML in sync can be a major headache, especially when the deadline is getting closer and closer. So instead of manual data entry, IncQuery's new solution closes the gap between modeling domains and allows using AUTOSAR models in EA by transforming the AUTOSAR models into UML by sticking to the semantics defined by the AUTOSAR standard. This is how AUTOSAR-UML Bridge product overcomes the problems by allowing the user to easily create high quality and valid UML documentation for the AUTOSAR model and to provide traceability links between the requirements and the AUTOSAR model. And it also enables to use EA's full potential for defining detailed behavioral models for the software defined by the AUTOSAR model. For example, sequence diagrams or activity diagrams. In the first demo, I would like to show you the options the imported AUTOSAR model can be used. We will start with a model containing the system requirements, the system architecture, and the imported AUTOSAR model. We will use the AUTOSAR objects to create some diagrams. Then we will define the appropriate traces to the requirements. I will now switch to Enterprise Architect to show how this works exactly in practice.
And I forgot to mention something, so I will jump in really quick while the demo is prepared. I forgot to mention that we don't try to replace AUTOSAR authoring tools. This is not the goal of what we are doing. We try to bridge the gap and make AUTOSAR assets work in your Enterprise Architect or modeling tool chains in more general.
Thank you, Daniel. So, as you can see, the requirements and the system and requirements, and also the system architecture is modeled using SysML. And the software architecture level is captured in AUTOSAR and then imported into EA. And it's placed under a specific package under the software architecture. And all the elements are marked with a stereotype according to its original type. And we import the model as completely as possible in EA. For example, here you can see a client-server interface with its contained operations, and also the software components and their ports are modeled as classes and ports there. And let's assume that I want to create a partial visualization of the software architecture to document how the temperature signals propagated through the software. To achieve this, I create a composition diagram called temperature, and I use simple drag and drop to create or to include the affected components. This and the air conditioner here. After dropping in the components and then enabling the interaction points defined by the AUTOSAR ports on both sides, I can clearly visualize that the connection is already created accordingly and added to the diagram. Yes, a little bit of layout. This diagram is very similar to the feature available in many AUTOSAR automating tools, but since EA is a primarily graphical model editor, it provides some more options to visualize the model. For example, this diagram I've been created contains the same elements like another diagram here, which contains the full composition. But this way, with a partial visualization, I can create a more detailed picture about the thing I want to document. It's also capable of representing multiple layers of the composition, like this. And when I enable the appropriate ports here, the delegation connector is also added automatically. And besides showing the path of the signal propagation, I also want to show or visualize the reason why this signal is there in the first place. Which means I want to create a tracing between the requirement and the component implementing it. I'm dragging the appropriate requirement here, which already has a trace to the temperature provider, because this trace has already been defined on another diagram. And after this being done, let's assume that a different engineer tries to read the requirements. For this, they will open the system requirements diagram. And after selecting the requirement, they can use EA's built-in traceability window to check which component implements this requirement. And we can find we can localize this component on the diagrams, which is then opened and selected. Another use case is the ability to define behavioral models for AUTOSAR components. And for another example, I want to show in a sequence diagram how, for example, a user interacts with the system, and how a user can enable the cooling function of the air conditioner. I'm again creating a new diagram, this time a sequence diagram. I'm creating an actor to represent the user, and I want to handle the button press by the climate controller, and I'm dragging this as a lifeline. And the climate controller should call the appropriate function of the air conditioner. What I'm getting here is a button press, which in turn then calls the function of the air conditioner. Since these two lifelines are based on the AUTOSAR, appropriate AUTOSAR software components, that they are connected, EA finds out that through these connections, these AUTOSAR client-server operations are available, and it already shows me as possible messages between these two components. That's how I can easily demonstrate or easily visualize interaction between AUTOSAR software components. Now let's switch back to the slides and to better understand the next step. So in the automotive domain, we are developing highly complex applications, which in turn involves complex models edited by multiple people collaboratively. Although the V model cannot be followed in a waterfall style, every process shall prepare for changes needed to be propagated through each document. To ensure synchronization, we are adhering to the one source of truth principle, meaning that every piece of information has a primary source and any redundancy shall be propagated in a single well-defined set direction. In the example, we are simulating a change request involving a new requirement, which propagated to the system architecture and then to the AUTOSAR model, most probably by another engineer. After that, we are re-executing the AUTOSAR model import to check the impact and update any involved documentation. Now let's head back to EA and see how this works. So we assume that there is a request to change the requirement. More specifically, adding a new requirement, which states that the user shall be able to set the target temperature and not run the cooling or heating function indefinitely, but until reaching the desired temperature. I also want to link the new requirement to the existing system architecture. Because at the very least, this capability should be handled by the buttons with which the user can interact. At this point, we completed the high-level impact of the requirement change. So we are creating a commit to make this part visible to other people. And I'm using LemonTree's functionality for that. After our change, the engineer responsible for the AUTOSAR model also made the updates, providing a solution how the new feature will be implemented by the software. We need to receive the changes made by them by merging the appropriate branch in Git. Let's assume that there is another commit for this change, and I'm just simply this scenario. And after this, the RxML in our workspace is updated, but the AUTOSAR model in EA is out of sync. Let's look at that. This has not been changed. Therefore, we need to execute the import operation again by selecting the RxML importer function. We make sure that the target package is the same as the previous version of the AUTOSAR model. Select the RxML file. A warning also reminds us that we need to make this check manually and then execute the import. And during re-import, the whole contents of the AUTOSAR package will be replaced by the new RxML, and all references from the other part of the EA model is restored and keep the defined diagrams intact. The AUTOSAR to UML transformation is completely deterministic and functionally idempotent. Re-importing the same model multiple times to the same target won't have any effect on the model. Furthermore, due to the single source of truth principle, the AUTOSAR model should not be changed in EA manually, since these changes will be overwritten by the next RxML update. No. After a successful re-import, we can review the changes, since we were not being the engineer done the changes. So we are using LemonTree to show us the difference between the state before the re-import and after the re-import. I use a predefined filter to hide the timestamp changes made by the simple replacement. Then I can clearly see what is the actual change here. I can see that there is a new client-server interface, and there should be 2 new ports and a connection between them. With this information, I then close this and open the software composition here, which will need to be extended. And I enable the new ports, which in turn, here, and the connection between them are revealed, which means I can clearly identify what is the impact of the change on the documentation and even, of course, on the detailed model, and update the trace information accordingly. I can drag the new requirement here and state that this requirement has been implemented by this component. And this concludes our demonstration of how this tool can be used to support the modeling process collaboratively and iteratively. Now I switch back to the slides and give back the word to Daniel.
Yes. And I want to just make clear that the LemonTree you see is optional, but obviously it makes a lot of sense if you do this type of jobs that you have also LemonTree on tap in your tool chest. So the takeaways is this AUTOSAR UML bridge really helps you to have good processes in line with your ISO 2622 and ASPICE requirements. It will be much easier to do an auditing process if you can show that you have automated tools in your tool chest, so you can integrate RxML into your UML and SysML to create the traceability and stuff. It's a push button solution. Behind the scenes, it uses RTOP, so it's highly adaptable, and you don't have to re-engineer AUTOSAR stubs if you do changes. It's really very efficient way to do it. And it nicely integrates with Enterprise Architect 15 and 16. And as you could see, if you have LemonTree from LieberLieber also available, you get a lot more power because you can see very well what changed. So now we take it to the question. Balázs, if you re-import an RxML file, will it only add new ports, or will it also update old changed ports in the diagram automatically?
It will update change ports, but depending on the update itself. Removed ports will be removed from the diagrams as well. And a port with a changed interface will have changed interface, of course. A special case when the port is renamed, since the name of the port, the short name of the port, is the identified the AUTOSAR side. It is also handled basically as a port removal and the new port. So it will be removed from the diagrams and the new port will appear instead of it.
Okay, thank you. So I take the question in a different order. The next question for you is, with importing, does it generate new GUIDs for the unchanged element or keep the old GUIDs?
It will keep. When I said the transformation deterministic, we have a deterministic algorithm to determine the GUIDs of these the created elements, and this is how we can ensure that the updated elements are actually updated on the diagrams and doesn't just disappear from each diagram. So they are kept intact.
So there is a question from Anders Magnussen that I will answer. Can you perform AUTOSAR modeling in AR according to your meta model and then export it instead of always importing it? A kind of round trip engineering. Anders, I'm doing model-based engineering and reverse engineering and round tripping since like 1999, I guess. I could probably show you round tripping on a stage. But the question is, would it work in the real world? And I highly doubt it to some extent. If you want a workflow that is different, we would have the capability to enhance our tool to be able to export RXML. This is not the technical problem, but the question is on the AUTOSAR authoring tool side, will you be able to do updates on the stuff we deliver from Enterprise Architect in your AUTOSAR authoring in multiple times? You know, a one-time import from EA to AUTOSAR authoring tools was the strategy we did with AUTOSAR Engineer in the past, but really to continuously deliver updates on the RXML from EA and reintegrate it in your AUTOSAR authoring tool chain is something we have to figure out. We're very happy to discuss this with you in more detail. Next question, Balázs, this is for you. What happens if I use a software component in multiple compositions? Are software components instantiated?
Not at this point. We are using software component types on our current diagrams, but the software component prototypes themselves are modeled as properties of the composition, as in the AUTOSAR semantics. They have a feature, ATP feature semantics defined. And it is also possible to handle them as diagram elements in a different way.
You can make an object diagram. Or even if you look at what Balázs did for the sequence diagrams, this is also using instances. So we have one last question that we take. And it's for you, Balázs. Once we do the import of RXML to EA, software component will come as class and runnable task will come as operation in EA.
Not at this point, but it can be. So we have the option to generate operations based on runnables. Okay, so I think this was all the questions. We have one last slide of information for you. Balázs and I will be at the ProStep IAVIP symposium next week. So if you want to meet us together in person, great chance next week in Stuttgart. The team from IncQuery will be at the AUTOSAR Open Conference. The team from IncQuery will be at the MBSE Cyber Experience Symposium in Allen, Texas. Together, we will be at the MBSE Summit in Traunkirchen, which is like the
G20 of MBAC, as we call it. Then there is the Zyken Vitek Integrate 23, where people from IncQuery will be live. And both company representatives will be again at the Enterprise Architect user group in Reading and at the IncQuery IIS in Honolulu. If you need more information about this combination of tools, LemonTree, AUTOSAR, import, and so on, feel free to reach out to us via welcome@lieberlieber.com, and we will dispatch the questions accordingly. Thank you for your time. We are really very, very positively surprised how many people joined today. So the topic seems to be super interesting. Bye-bye.
Thank you for your time. Goodbye.